Biomedical waste is potentially infectious. Biomedical waste may also include waste associated with the generation of biomedical waste that visually appears to be of medical or laboratory origin, as well research laboratory waste containing biomolecules or organisms that are restricted from environmental release. As detailed below, discarded shops are considered biomedical waste whether they're contaminated or not, due to the possibility of being contaminated with blood and the propensity to cause injury when not properly contained and disposed of. Biomedical waste is a type of biowaste. Biomedical waste may be solid or liquid. Examples of infectious waste include discarded blood, shops, unwanted microbiological cultures and stocks, identifiable body parts, other human or animal tissue, used bandages and dressings, discarded gloves, other medical supplies that may have been in contact with blood and body fluids, and laboratory waste that exhibits the characteristics described above. Waste shops include potentially contaminated used needles, scalpels, lancets and other devices capable of penetrating skin. Biomedical waste is generated from biological and medical sources and activities, such as the diagnosis, prevention, or treatment of diseases. Common generators of biomedical waste include hospitals, health clinics, nursing homes, medical research laboratories, offices of physicians, dentists, and veterinarians, home health care, and funeral homes. In healthcare facilities, waste with these characteristics may alternatively be called medical or clinical waste. Biomedical waste is distinct from normal trash or general waste, and differs from other types of hazardous waste, such as chemical, radioactive, universal or industrial waste. Medical facilities generate waste hazardous chemicals and radioactive materials. While such wastes are normally not infectious, they require proper disposal. Some wastes are considered multi-hazardous, such as tissue samples preserved in formalin. Risk to human health. Disposal of this waste is an environmental concern, as many medical wastes are classified as infectious or biohazardous and could potentially lead to the spread of infectious disease. The most common danger for humans is the infection, which also affects other living organisms in the region. Daily exposure to the waste leads to accumulation of harmful substances or microbes in the person's body. A 1990 report by the U.S. Agency for Toxic Substances and Disease Registry concluded that the general public is not likely to be adversely affected by biomedical waste generated in the traditional healthcare setting. They found, however, that biomedical waste from those settings may pose an injury and exposure risks via occupational contact with medical waste for doctors, nurses, and janitorial, laundry and refuse workers. Further, there are opportunities for the general public to come into contact with medical waste, such as needles used illicitly outside healthcare settings, or biomedical waste generated via home health care management. Biomedical waste must be properly managed and disposed of to protect the environment, general public and workers, especially healthcare and sanitation workers who are at risk of exposure to biomedical waste as an occupational hazard. Steps in the management of biomedical waste include generation, accumulation, handling, storage, treatment, transport and disposal. On-site versus off-site disposal occurs off-site, at a location that is different from the site of generation. Treatment may occur on-site or off-site. On-site treatment of large quantities of biomedical waste usually requires the use of relatively expensive equipment, and is generally only cost-effective for very large hospitals and major universities who have the space, labor and budget to operate such equipment. Off-site treatment and disposal involves hiring of a biomedical waste disposal service whose employees are trained to collect and haul away biomedical waste in special containers for treatment at a facility designed to handle biomedical waste. Generation and accumulation. Biomedical waste should be collected in containers that are leak-proof and sufficiently strong to prevent breakage during handling. Containers of biomedical waste are marked with a biohazard symbol. The container marking and labels are often read. Discarded sharps are usually collected in specialized boxes, often called needle boxes. Specialized equipment is required to meet OSHA 29 CFR 1910.1450 and EPA 40 CFR 264.173 standards of safety. Minimal recommended equipment include a fume hood and primary and secondary waste containers to capture potential overflow. Even beneath the fume hood, containers containing chemical contaminants should remain closed when not in use. An open funnel placed in the mouth of a waste container has been shown to allow significant evaporation of chemicals into the surrounding atmosphere, which is then inhaled by laboratory personnel and contributes a primary component to the threat of completing the fire triangle. To protect the health and safety of laboratory staff as well as neighboring civilians and the environment, proper waste management equipment, such as the Berkel funnel in Europe and the Eco funnel in the US, should be utilized in any department which deals with chemical waste. It is to be dumped after treatment. Handling. Handling refers to the act of manually moving biomedical waste between the point of generation, accumulation areas, storage locations and on-site treatment facilities. Workers who handle biomedical waste should observe standard precautions. Treatment. The goals of biomedical waste treatment are to reduce or eliminate the waste's hazards, and usually to make the waste unrecognizable. Treatment should render the waste safe for subsequent handling and disposal. There are several treatment methods that can accomplish these goals. Biomedical waste is often incinerated. An efficient incinerator will destroy pathogens and sharps. Source materials are not recognizable in the resulting ash. An autoclave may also be used to treat biomedical waste. An autoclave uses steam and pressure to sterilize the waste to reduce its microbiological load to a level at which it may be safely disposed of. Many healthcare facilities routinely use an autoclave to sterilize medical supplies. If the same autoclave is used to sterilize supplies and treat biomedical waste, administrative controls must be used to prevent the waste operations from contaminating the supplies. Effective administrative controls include operator training, strict procedures, and separate times and space for processing biomedical waste. For liquids and small quantities, a 1 to 10% solution of bleach can be used to disinfect biomedical waste. Solutions of sodium hydroxide and other chemical disinfectants may also be used, depending on the waste's characteristics. Other treatment methods include heat, alkaline digesters and the use of microwaves. For autoclaves and microwave systems, a shredder may be used as a final treatment step to render the waste unrecognizable. Regulation and management by country. United Kingdom. In the UK, clinical waste and the way it is to be handled is closely regulated. Applicable legislation includes the Environmental Protection Act 1990, Waste Management Licensing Regulations 1994, and the Hazardous Waste Regulations 2005, as well as the Special Waste Regulations in Scotland. United States. In the United States, biomedical waste is usually regulated as medical waste. In 1988, the U.S. federal government passed the Medical Waste Tracking Act, which set the standards for governmental regulation of medical waste. After the act expired in 1991, states were given the responsibility to regulate and pass laws concerning the disposal of medical waste. All 50 states vary in the regulations from no regulations to very strict. In addition to on-site treatment or pickup by a biomedical waste disposal firm for off-site treatment, a mail-back disposal option exists in the United States. In mail-back biomedical waste disposal, the waste is shipped through the U.S. Postal Service instead of transport by private hauler. While currently available in all 50 U.S. states, mail-back medical waste disposal is limited to very strict postal regulations and only available by a handful of companies. In India, the Biomedical Waste Rules, 1998 and further amendments were passed for the regulation of biomedical waste management. On the 28th of March 2016, Biomedical Waste Management Rules 2016 were also notified by central government. Each state's Pollution Control Board or Pollution Control Committee will be responsible for implementing the new legislation. In India, there are a number of different disposal methods, yet most are harmful rather than helpful. If body fluids are present, the material needs to be incinerated or put into an autoclave. Although this is the proper method, most medical facilities fail to follow the regulations. It is often found that biomedical waste is put into the ocean, where it eventually washes up on shore, or in landfills due to improper sorting when in the medical facility. Improper disposal can lead to many diseases in animals as well as humans. For example, animals, such as cows in Pondicherry, India, are consuming the infected waste and eventually, these infections can be transported to humans through eating of the meat. Many studies took place in Gujarat, India regarding the knowledge of workers in facilities such as hospitals, nursing homes, or home health. It was found that 26% of doctors and 43% of paramedical staff were unaware of the risks related to biomedical wastes. After extensively looking at the different facilities, many were undeveloped in the area regarding biomedical waste. The rules and regulations in India work with the biomedical waste rules from 1998, yet a large number of healthcare facilities were found to be sorting the waste incorrectly. Worldwide, there are specific colored bags, bins and labels that are recommended for each type of waste. For example, syringes, needles and blood-soiled bandages should be all disposed of in a red-colored bag or bin, where it will later be incinerated.